I asked this question already and you answered a couple times. You guys have already covered events in 1666, right?
Oh, yeah.
So when you are in the designer, right, and then you drag and drop, is it drag and drop for the Windows forms, or you have to? Yeah.
I mean, that is an event that we can do.
Yeah, no, but when you add in controls like buttons or so, you drag it from the tools and drop
Yeah, you
it?
go from your toolbox, drag it
Yeah.
onto the form.
Well, because the thing is, I haven't done Windows forms in
Oh,
years.
yeah, you go to your toolbox, drag and drop, double
So,
click.
Yeah, I mainly do WPF now, so I have forgotten about it. And that was the new stuff now, like WPF is also become the new. So, Windows Forms is double obsolete because, yeah, WPF, I don't say it's becoming obsolete, but eventually will. Anyways,
It is old.
so when you drag and drop a control and then you double click on it, it opens a special method, right? That is an event handler.
into your .cs
Yeah.
file.
So in this case, it's kind of similar, except that the event is not going to be a button press. It's going to be some hardware event, okay? And just to understand this, I call this one main, but I refer to mainly to the main infinite loop that we have. We are executing that all the time. So in Windows machine or any computer machine is different because you have multi-threading. So that thing happens like automatically when you click a button, it fires the event and everything else keeps happening in the background. Here, we only run in one thread. So if that event actually happens, we need to jump into a special function, okay? And this special function is called ISR, as in interrupt service routine. Examples of this: when you're using the usearts and you receive a character. So far, we've been just polling all the time. And the perfect example for that, I think I gave this example in the past, but I'm going to repeat it so you can get the idea. So let's say you're working on an in-class assignment, and I come to you every 10 minutes to ask if you're done. So I come, are you done? You say no. I come the second time, after 20 minutes, are you done? You say no. Then I leave, and I come back at 30 minutes, but it happens that you're done at minute 21. So there's no way for me to know that you're done until I come to you and I ask. That is what is known as the method of polling. So me, who is like the main program, is polling you guys how your work is going. But I'm doing it at my own pace. So that can have very large delay depending on how busy I am, right? And how much time do I take to come to you. So it would be different if whenever you are done, you just raise your hand and then you interrupt me. So then I can stop what I'm doing, go and attend right away. So that is what's happening in this case. When we configure an interrupt to happen, then the program, there's a register here that, which acronym is PC, as in program counter, that keeps track of the address of where the program is at, because every line of code has an address, okay? When you flash your program into the memory, every line that has to be executed has an address, okay? So the program counter is keeping track of that. But when an interrupt happens, it saves the value of the program counter, it jumps out of the main loop, goes to service this small routine, okay? And then, since it has the program counter saved, it goes back to exactly the same line where it left, okay? And it continues to execute the program. That's kind of the idea. Now, if we go back to this idea of me polling or you guys working on assignments, let's say that we implemented the interrupt, and let's say Rosine is ready, so she raises the hand to call me, but at the same time Rex is also ready, so he also raises the hand to call me. So what do?
You go to the person that raised their hand first.
What if both do it exactly at the same time?
Then you decide where to do first.
Yeah, there's gotta be some sort of priority, okay? That's one thing. So when two things happen at the same time, there's gotta be some sort of priority. And I always do a bad joke about it. I say I go to the student that I like better, but that shouldn't be, because I should like everyone the same, right? So then that doesn't apply. But there's gotta be some sort of priority. I can't be in two places at the same time. That's one example. The other example is, what if I decide to go with Rosine, and then Rex gets pending, and then Rosine spends half an hour asking me questions back and forth. Then what happens? Everything else gets delayed, right?
Yeah.
So that cannot happen. So it needs to be quick. Which is why, by the way, when I do the checkouts in the exam, ideally you call me when you're ready, when your scope is in sync, your trigger signal, everything, because I cannot spend more than 30 seconds doing the checkoff because I have to attend some other checkouts, right? Here's the same idea. When your program jumps out of the main loop to attend a small interrupt service routine, the code here has to be quick because the program gets interrupted. So it needs to deal with it quick and come back here, okay? Moreover, things can get really complicated if you are in your ISR1 and suddenly ISR2 fires because another event happens, and if this one has a higher priority, it may jump to this one, then go back to this one, and then go back there. So things can get really complicated, okay? It's not that you call one ISR and then the other one has to wait. If the other one that comes has a higher priority, then you'll have to jump out of that one and go to the higher priority one. That's kind of the way it works. And in real life, it's the same thing. When you're working on a task, but then suddenly something higher priority comes up, then you gotta deal with that first, and then you go back to the other task. Okay, so now, if we go back to the beginning, how do the peripherals communicate with the main program? Remember that? How do I know the USART received the character?
Through the RDR.
There's a flag that I check, right? Okay, so that flag exists in some status register, right? How do I know about it? Because the program polls the flag. Now, what the interrupts do, what they do is in the configuration register, you enable the interrupts. So once you enable the interrupt, that flag, instead of being polled, is automatically going to trigger this interrupt service routine. Okay? So the hardware will trigger the events. How is that going to happen? Well, there's a few things that we need to specify, but this is more or less the model. Okay? So the interrupt has to be first enabled in some register. So when the flag becomes active, that's going to fire the ISR, and the ISR is a special function that needs to have a special name. They're all listed in a file, so it can't be named anything. Okay? That being said, let's start with the lesson then, because that was a sort of like an intuitive approach. So we're going to describe the purpose and the benefits of using interrupts in embedded systems. We're going to configure, the first interrupt that we're going to show you is the USART interrupt, okay? And hopefully by the end of this or next class, we do understand the difference between polling and interrupt-driven programming. What are interrupts? So an interrupt is a hardware-triggered event that causes the microcontroller to temporarily halt its current execution and jump to a predefined routine called interrupt service routine, ISR. This mechanism allows the system to respond immediately to critical events without constantly polling for changes. Okay? So for things that are critical, interrupts are very useful. And I'm going to show you the USART example. Internal peripherals can trigger an interrupt, timer, user, ADC, or external sources like a button press or a sensor, whatever. Why do we want to use interrupts? Well, again, interrupts are essential for having a responsive program that is efficient and allows the CPU to, or the MCU, to coordinate input-output tasks without wasting CPU cycles on calling, okay? Responds to time-critical events like incoming data, serial data, or sensor thresholds. If something goes beyond the threshold, immediate response. Handle errors, that's also important. If something happens, we should react right away. Perform routine tasks at fixed intervals. So what if something needs to happen like every millisecond? Then you cannot really have that in your main loop, because if your main loop grows, your infinite loop, that millisecond starts to get off. So if you need something to happen exactly every 1 millisecond, then you need an interrupt. We talked about priorities, interrupt masking, and prioritization. Now, this nomenclature is a bit confusing. When an interrupt is masked, we say that it's disabled or inhibited. Okay? And when it's unmasked, like uncovered, is the process of enabling. Okay? So this thing gets a little bit confusing. That's why we have interrupts that are maskable and some interrupts that are non-maskable. Okay? The ones that are not maskable, what actually does it mean? That they cannot be disabled. Another bad joke for this one is like you can have a supervisor at work, a coworker. You can decide if they interrupt you or not. If you are senior enough, you can just say basically your supervisor, come back later, I'm busy, right? But what if the CEO of the company or someone like higher? You probably don't want to do that, right? So that should be considered like a non-maskable interrupt. When that one comes to you, then you're gonna get it. But the best real example for this is your reset button. So if you look in this schema here, the reset button has the highest priority. In fact, these numbers here, they start to grow from 0, but they are even negatives. So the higher the number, or the lower the number, the higher the priority. And this one is -3, so it's less than 0. And that is your reset. So, and it's a non-maskable interrupt. There's no way that in your program you say, you know what? I'm going to disable the reset button so it doesn't reset the micro. There's no way. It's not unmaskable. So when you press the black button, the micro will reset no matter what, and that is an interrupt. And it happens here. There's also the hard fault, which is the typical that gets triggered when you reach a null pointer or something like that. So these are called more like interrupts. These are exceptions. And from 16 and above are all the ones that are configurable and maskable. So those you can enable or disable. All right? We're going to revisit this next slide anyway, so don't worry too much if things are a bit confusing. So what is the process for enabling an interrupt? So it involves two parts. The first part is go to the peripheral, to the actual control register, and enable the bit there. So the control register one for the user has a receiving interrupt and a transmitting interrupt. The transmitting interrupt is not very useful, but the receiving one is very useful. So whenever you receive a character, you can now interrupt. Aside from that, you need to call this NVIC functions. NVIC stands for a Nested Vector Interrupt Controller, and it's a peripheral that is inside the core of the micro. So it's across all Cortex-M micros, okay? And it's the same. And every peripheral has an IRQN, so as an interrupt request number, okay? And where do I find these interrupt vectors and the IRQNs? So the vectors are actually the pointers to the functions that get called when the interrupt happens. In that table, how do you find it? You go to the system files of your project in Sager, and you will find 3 assembly files, and the one that has the micro serial and underscore vectors, that one includes all the vectors for the different peripherals that you can use interrupts for. And these are the ones that belong to this mic. So you should note that some of these vectors are shared. For example, for the USR2, it's also shared with a low power UR2, which is a different UR. Okay? For the timers, for example, the timer 7 is also shared with low power timer 2. You see, some of these vectors are shared, so you have to be careful with that. But what I'm trying to explain with this, if you want to use interrupts with the USR2, the function that you need to code needs to be called what? USR2 underscore whatever IRQ handler, okay? So it's a special name for the function. So you get the names from here. In the IRQNs, which are the numbers, see, when you enable the actual interrupt request with this special function that is part of the CMCs, where do you look for those numbers? They are in the derivative file, and the one that you include, this one. You click on that one, you go to that file, and you will find the list of all these ones. See, the non-maskable ones have negative numbers. So there's nothing you can do about those, but these other ones can be enabled or disabled. You have the watchdog, and the priorities are here. You can actually play with the priorities later, you can change them. And the USART should be somewhere in here, and it's named very similar to the vector. It's just that it's underscore IRQN. The functions, the intrinsics, or functions that are part of the CMC's standard, they are in here, and all of them, you can use them to enable the IQ, to disable it, to get the pending one, to set pending, to clear the pending, to set the priorities. We're not going to use all these ones. Most likely we're just going to use enable and clear pending, okay? And also, you can use these macros that are actually to enable the interrupts globally or disable them. So you can just disable the interrupts entirely, and if you use this one, it doesn't matter whatever interrupt you configure, it won't get triggered because this is disabled globally. And if you really want to understand how the nested vector interrupt controller works, you can look at the M0 Plus core manual. That there's the same manual, but there are 2 versions, by SE or by ARM. This is quite an advanced manual, which is why we don't include it. It's more advanced than the reference manual. The reference manual, we use it to look at the registers, the bits that we have to clear and set. This one is more advanced because it has to do with the core. But we don't have to master writing or reading to these registers because we can just use these functions that are provided to us by the standard to handle the interrupts. So that makes it a bit easier. Okay? Any questions up to this point? Of course, we're going to explain this further in this following lesson, next class, and we're going to do examples, and we're going to do everything, and we're going to do it step by step so we can kind of get used to it. Okay?
So all of these interrupts are happening outside of our main loop?
Yeah. Okay. Yeah. So I added a demo. Demo 31, and let me just open it. I'm not going to code any interrupt, so I'm going to call it a day after this, but I want to show you something. So you can start feeling what is the necessity of interrupts. So I grabbed a demo that uses the USART that is going to buffer the receiving data, just like we did before, remember? And it's going to process when it receives a character. Okay? So for now, I'm going to delete this one, commented out. And basically this processing, all it does is just sends back whatever you received. And in order to test this effectively, I don't want to use TeraTerm because TeraTerm sends the character right away as soon as we type it. So we want to be able to collect the characters and send them all at once. Oops. Let's take a look here. Come on. So we connect at 115.200, and for example, I say hello CMP 1250, and nothing's going to happen until I hit enter. And when I hit enter, oops, I need to be connected, of course. Oh, why I cannot connect? Let's rescan. Oh, maybe it's not 59, it's a different COM port now. It's 51. There you go. I'm going to say hello CMPE 1250. What's happening? Oh, kind of crashed. Okay, so first let's see which port is the USART. So the USART is COM65. Yeah. So this guy is not even close. Very beautiful.
Go to your task manager and just kill it.
I don't think I can kill things from the task manager because I'm not admin. Oh, maybe I can.
You should just be able to, yeah. Interesting.
Oh, I think he selected a different task. Okay, there you go. Okay. Oh, I'm able to actually. Okay, open it again. Terminal. It's a 32-bit app. So we need to get a better terminal to do this. Anyways, so I'm gonna scan the ports again. So COM65 should show up somewhere here. It's not showing up. Huh. That's interesting, because I saw it here. It's a JLink. So you know what? It might be taken. That's not good. I'm gonna have to restart the whole thing. Yeah.
Yep, you're gonna have to restart the whole system.
Yeah, because it's
Something's locked up.
oh
Yeah, you can see it there. Yeah.
yeah, I didn't want to give up. Or maybe I managed to kill it. Let me see. One more time. One more chance. So we don't have to restart this guy. Yeah, that's a problem when you open a serial port. If the application doesn't release it properly, it can be really a nightmare.
Stuck.
No. Yeah, still, okay, still.
Yeah, it still has a process running in the background, even though it doesn't.
Okay, so we're gonna have to restart. My goodness. Yeah, because it's still taking there. Windows. That's why I'm switching to Linux.
Already done.
Kill -9, and then the PID, and that's it.
Well, I mean, depending on your distro, you can just literally write the word kill and then the name of the process, and it will just.
Yeah. This long weekend, actually, I think I told you guys. Oh, the other section I told. I did install a VM with Ubuntu, the latest version. And then,
2404.
yeah, and then I installed the Sager Embedded Studio waveforms and all the tools, and it runs like amazing well on a VM. So then over the summer, I'm going to have a dedicated computer to run Linux and install everything needed. And I'm really looking forward to it.
Just get a new NVMe SSD. I
Mhm.
would not suggest putting them on the same drive.
Yeah.
Like, you can dual boot as well.
Oh no, I'm gonna have a dedicated computer.
Interesting.
Yeah, no, I'm not doing the dual boots because I've done it in the past and sometimes Windows kills the partition.
It can on the same drive. If you
Yeah.
have them on separate drives, it takes care of the issue.
Oh, that's a good advice actually.
Is this what I did? And then all you have to do is just point your bootloader to the Windows bootloader. So then, and then you have
Or you
your,
can tell it boot from this disk, whatever.
so then your Linux bootloader is the first one in the priority, but once it's picked up that you pointed it to a Windows bootloader, it gives you a selection screen after you've passed your BIOS screen that allows you to select which OS to boot into.
Hmm.
But it's also cool having a dedicated machine as well.
Yeah, probably the laptop, I'm just gonna make it Linux and keep
If
the
it's-
desktop as Windows.
If it has a dedicated GPU with NVIDIA specifically, you will have to play around with some of the dependencies for your desktop environment.
Oh, okay.
But if it's an AMD GPU, it's just natively supported on the kernel, so.
Oh, that's good to know.
Also, if you have like a laptop and you use Linux on it, you have to configure the brightness, right? Because you can't do the slider, right?
Oh, okay. Yeah.
Yeah, it depends on the laptop model.
Yeah.
Oh, you guys seem to know quite a bit about Linux. That's good.
I'm dual booted on
Yeah.
multiple systems.
Well, it's interesting that in the embedded systems world, there's a lot of Linux development, and a lot of tools are created mainly for Linux, and then they are created for Windows.
Cider
after.
works better on Linux than it does
Yeah.
on Windows.
So it's worth exploring, and there are so many tools that we can
Also,
play
the servers
with.
are in Linux.
All the
that
applications
backbone.
were made natively for a Linux distribution, and then they were ported to Windows afterwards.
Yeah.
Yeah, because of all of the open source stuff, and then it's way better, to develop for.
Also, Git just works better on Linux through the terminal.
Yeah, in Linux, you don't even have to install. It comes with pre-installed serial terminal. You just call it from the main terminal.
It's just
You open the
pre-
port and that's it.
Yeah.
Okay, now it has to work. Come on.
About to find out
No,
if there's an issue with the application.
but this is happening just with this board. What the heck?
It was working yesterday.
Yeah, because I had it working yesterday, so I don't understand.
The other thing is it could have some data that's been cached in a file folder. You might just have to clear that cache.
65, and so how come this port is, you know what it could be? You know what I'm gonna do? I'm gonna change it to a different one. Hopefully it changes the number. It's G65.
COM65.
But how come this guy is only recognizing COM1 and COM?
That's annoying.
Okay. No, it won't let me. What the heck? It's the first time I see this problem. I think I might know, this could be a driver issue. See, and unfortunately I cannot play with this thing because I don't have admin rights.
No, it'd be easy if
Okay.
you could just grab the driver file and
So
install
I'm gonna
it.
use the other board because that one has worked before. Well, it's just because Windows doesn't. I've been working with the other board all the time, so
There's
that one
more
is.
vibe coding on Linux than there is on our assignment, bro.
Say that again.
There's more vibe coding on Windows than there is on any of the.
See, this one does recognize it. Okay,
Interesting.
so what we're gonna do here, we're gonna do this. Hello CMP 1250. And since this is not running, of course, it's not returning anything. So now, okay. which one is the one number? Oh, I'm running the exam thing here.
Oh, yeah, that might.
Ah, my goodness. Okay. So I'm gonna do this no matter what. So I'm a stubborn person. So even if we have to stay till 10, I'll do it.
He's gonna create his own terminal application.
Even
just
if
so
it's
that-
just by myself here. I'll show it to myself. If everybody decides to leave, just to be clear, I'm gonna do this anyway. Okay. All right. So I send that. Beautiful, beautiful, right? So basically I'm sending back whatever I receive, right? Now, let's say in the main loop, there's a little bit of overhead that's going to be represented by this delay 50 microseconds, because the ticks for this one is microsecond ticks. So 50 is going to be 50 microseconds. So the obvious question here would be, why would you do this, right? I asked the same question yesterday. Well, I'm doing this on purpose to show you something. Now, obviously, if I had a choice, I would not insert this blocking delay here. But this blocking delay could be any other overhead created by something else that gets executed. Because remember, your program will start growing, it will start adding time. Okay? So if I do this now, and I insert that little blocking delay here, and I send this hello CMP 1250, it gets more or less received well. Okay? Yeah, because that was the last number I was playing with. However, if I put it to 150, now 150 microseconds, and I do this again, now the characters started to get lost.
Interesting.
And it's very random. Now, does anybody remember when I'm at 115 to 100, how long does it take for one character to travel through the, we did the calculation. Does anybody remember?
I don't remember the number.
Yeah, it's about 87 microseconds per character, which is why 50 is still not too bad, because it's still within the range. So when I press enter here, what happens is that the terminal graph every single character and starts sending one by one after the other. And each one is going to take about 87 microseconds. Now, if my program, for some reason, is stuck in here for longer than 87 microseconds, then I'm going to start losing characters. Because every time I loop through, if there's a character, it will be received and added to the buffer, right? And the logic will be handled and all that. So I do have a problem. So it's something that I've been hiding from you guys in the past, but now it's time to expose it. That when you have this overhead here, if it takes longer than the time that it takes for one character to travel, if you're sending the characters one after the other, you're going to lose characters. Why won't you notice this in Teraterm? Because the moment that you press something in Teraterm, it gets sent right away. And you can definitely not type at 87 microseconds per character. That would be insane. That would be like, yeah, like 10,000 characters per second. It's impossible, right? However, if you put in all of them in the terminal and you hit enter, there you go. So how do we solve this problem? Because this is something likely to happen. Like when, remember, you have to think scalable. Like when we integrate this part to a larger application that has lines and lines of code, you're going to inevitably start adding overhead to the main loop. So how do we solve this problem?
Previously, we would have inserted most likely another blocking delay on the, because if we're blocking the transmission, or sorry, this is blocking the receiving, so we'd also want to also delay the transmission by a similar amount to offset that. But now it looks like we want to
you
use
don't have
flags.
control of what else is going to be added here. So this approach of polling is definitely undeterministic. Like it's not something that you will use professionally, because you cannot tell your boss, you know what, I've reached a point where I cannot add any more lines of code because otherwise I'll start missing characters when I receive a message. You can't do that. So you need to be able to handle it. So these get solved with an interrupt. So the moment that you receive the character, it's going to jump out of the main loop, go to the ISR, and put it into the buffer. Now, Are you going to do all this also in the ISR? Like send the message back? Yes or no?
Sorry.
Are you also going to put this code, these 3 lines in the ISR?
No.
No. Why? Because this also takes time. And remember when I gave the example that what if Rosine has me talking to her for half an hour? Not good for the rest of the students. What if the user interrupt is taking so many milliseconds just to do this? Not good for the rest of the program. So what do we need to do? Receive the character, put it into the buffer as quickly as possible, and set a software flag. Well, only set the flag here. When you receive the character, you can say something like, I don't know, command complete or process. You set your process flag to true. Then in your main loop, you're gonna say, instead of doing this, you're gonna say if process, now you process. You got all the data in your buffer already. Now you can do all this stuff that takes time. But when another interrupt is received, the program is gonna interrupt again. So I don't have time to show you that in execution, but next class, I'm gonna grab this demo and I'm gonna do the interrupt steps, and you're going to notice that it doesn't matter how much delay you put in here, you're not going to lose a single character. Not at all. Everything will be received. Any questions?
Sorry, you said polling is not a professional thing?
Especially for the you or no.
Then
No.
why are we talking?
Yeah. That's a fair question, and I get that question all the time.
Yeah.
Like,
Unless you-
okay, we started doing these delays in cycles.
Yeah.
And then I said, what did I say?
So this
Dump
is
the delays in cycles, we're not gonna use them anymore, we're gonna use
useless
timers.
now, we're using timers.
So then the obvious question was, why did we even learn it in the first place?
Yeah. My question.
You need to learn the concept first before.
Well, because learning is a process. I cannot jump. See, if you look back, how did we start in this course? Can you remember the first thing that we started doing?
Struggling learning C.
Yeah, I'm trying to understand the IDE. We cannot throw everything on you at once, so we need to go in steps. And learning is the process of you realizing, oh, now I got these tools, I can do it this way, right? But why did we learn something that we're no longer going to use? Well, because that was part of the process. It was necessary to take you to a level where you can actually understand the more complex stuff. And believe me, if I started using interrupts right away, it would have been a bit of an overkill, and you guys would have been very confused at the beginning. In fact, some other instructors still believe that we shouldn't cover interrupts at all in this course, and I highly disagree with that. I strongly disagree with that, because the more we delay this process, the more difficult 2250 will become. So I want to come to 2250 with at least the idea of what an interrupt is, so that in 2250 we can start handling multiple interrupts. Because then we have to deal with the complexity of the priorities and all that stuff, but at least we have an idea. For now in 1250, we're gonna keep it simple. We're gonna use one interrupt, at most 2. But it becomes very interesting when you start having like 10 interrupts at the same time, right? Because then how do you deal with that?
Eventually.
Yeah. So that's why the priorities are important.
What'd you debug that?
With
Yeah, you need to place breakpoints in strategic, spots.
a lot of time, man.
Any other questions? That was a fair question. Yeah. Now, for the UART in particular, not everything has to be with interrupts. So the transmission can still be blocking, right? But the receiving cannot be polling, because we already demonstrated why it's not professional. Because the moment that your program starts having overhead, then you're gonna lose data. And is that something that you can afford in a program? No.
No.
Lose data, no. Imagine an airplane that loses data like from the sensors. Cannot.
People die and you get fired.
Yeah, so critical things. All right, so I think I've talked for quite a long time and consumed most of the time, but on Friday we'll revisit this. Check off.